previously, for those who did the CCDA version 1 and 2, we had this method called the PPDIOO. Now Cisco moving away from this to the PBM. So let's have just a quick look at the other one, which was the prepare, plan, design, implement, operate, optimize, and then we go back to the prepare. So it's a life cycle. It is a framework. Everything we said before apply to this. So when you implement, when you deliver, you are an expert at it. It's a better implementation. If you put in place monitoring solution, so when you operate, then you can optimize better. So at some point you can detect a point of contention, and then you can prepare to the next refresh of hardware or the next deployment. So that was for the PPDIOO. Now the good thing is, well, Cisco, as you can see, went from 6 letters to 3 letters. So might seem like easy. And for those veterans that did the version 1 and 2, and for those people still using the PPDIOO framework, you know, it is pretty important to Cisco. So we're moving now to the plan, build, manage. So if we look at this wheel, it's pretty analogous to the previous one. So we plan, then we build, we manage it, and then it leads us back to the plan. Under the plan, there are a couple of sub steps: strategy analysis, assessment, design, and for the build is validation, deployment, migration, and for the manage would be product support, solution support, optimization, operations management. And in the middle, the smart service capabilities, which is the smart service and a smart call for those that are long-time Cisco engineers. It's part of their solution. It's within licensing plan. I will not dive into this. Most of you probably have an opinion around this, but this is really, it really ties every 3 steps together. So the first one of the PBM is the plan. So when we plan, well, strategy and analysis, assessment, and design. Well, let's go back to the previous one just quickly. See, so we have the prepare, the plan, and design. If we look on the right, under the plan, we have the analysis, which is just a description probably of steps we had under prepare. Then the assessment and the design. So strategy and analysis. Well, first you will propose a high-level concept. So that's part of the strategy. Identify the technologies, that's part of the analysis. So your customer has a goal, customer has a problem, customer needs to refresh, customer is purchasing another enterprise, adding more branches, so they need a strategy. So you need to propose a high-level concept. How do you do this? Well, you identify the technologies. What are the technologies in place? What kind of technologies can be added to it? You establish milestones, and from past experience, customer really appreciate the milestones. Those are steps to reach at certain point. It kind of reassure also your customer, and like I said, I say customer all the time. An internal customer, let's say you work at Starbucks. You're a network engineer at Starbucks. Well, your customer is Starbucks. So that's why I always say customer. You identify the resources. So even if you have the best plan, even if you're thinking, well, let's go with a 10 megabit connection between these two buildings, we'll lease a 10 megabit from the ISP. Well, if your ISP is not providing a 10 megabit, well, the resource is not available. You'll have to fall back to something else. I've seen remote places where they have to actually fall back to wireless LAN. So the resources are not always there. It's really important you identify them. Walkthrough of operational environment. That really applies to solution architects, solution engineers. Sometimes the solution architects likes to bring their solution engineers with them. So what actually happens is that you have your customer, they have a goal to achieve, and you have identified the resources, the technologies, but you're preparing the high-level concept. Well, a walkthrough that would be actually going on site, see what the data center look like, what the branches state look like. Is it a cabling spaghetti? Is the at first sight, is the cooling capacity sufficient? Power capacity. So all these can be quickly identified through a walkthrough. Then under the plan, we still have the assessment. So a network assessment, gap analysis. So network assessment and gap analysis. Well, this with depending. Well, if it's an internal job, probably this will be done. You will pull metrics of your network. You will find your actual point of contentions. If it is a bandwidth problem, latencies, endpoints. If it is, let's say, a voice over IP delivery or a video delivery. Gap analysis. So to reach this level of performance, what do we need? How far are we to our goal? Determine the scope, cost, and resources. Then align with business requirements. And that's a very key element. It's really easy to walk in, look at the equipment, and say, well, you know what? We need to refresh everything. This equipment is not up to the requirements, and then we need to refresh everything. The thing is, and it's in real life, you might not have the budget, so you're not meeting the business requirements. Because the business might require you to be under a certain threshold in terms of budget. The resources, like I said, you might not have the resources, just plain and simple. So you really need to size the business requirement, the scope also. If you need to add a branch, well, it's a branch you're adding. It's not a when you're redoing. So you really need to scope this. And the design. Well, at this point, you should provide a detailed design. So you did your walk-in, you did the assessment, you sized the cost of the equipment, scope of the project. So you're actually now designing, and it should be a detailed design. The high overview was already done in the first meeting, well, following the first meeting, and then now you're at the level where you're doing a detailed design. Network diagrams should be done also at this point and should be provided to your customer. the BOM, the bill of material, to back up your budget that we see previously. So if we go back here and we'll look at it, so the scope, the cost, and resources to scope this out was to actually build your bill of material. I think it's kind of important for your customer, and it's kind of important for you too. Then the project update is more granular. So at this point, it would be small things like, I think we go with a smaller license on switch 22 because we're not planning to have any servers attached to that one, only workstation. We looked at the BOM and the extra cost for security is too much. We'll rely on another infrastructure for the security, so we'll reduce the licensing on these actual boxes. So it's really granular. We're adding two more licensed port SFPs to a Nexus switch, and then you end up with your scope of work. And if you're doing the actual delivery, that's something you need to deliver at this point. So if you have a detailed design and you have network diagrams, you can ask your engineer, well, how long is this going to take you to deliver actually? So you can deliver a scope of work. Then we switch from the plan to the build. Under the build, we'll have the validation, which is a new thing. It wasn't part of the PPDIOO. The deployment and the migration. Migration is kind of a rebadging of parts of the previous iteration of the PPDIOO. So the validation, well, for those interested, it's a suite of procedures to validate and optimize service. And like I said, this is a Cisco exam. So when they say you validate against a Cisco validated design, against Cisco hardware. So if you go on Cisco's website and you pull the test and validation PDF, you'll see they have a lot of products to validate the design. If you're going to actually validate your design yourself, well, you need to identify how the changes will affect the production network. So you validate that if you put it on site. So it's just, let me simplify, oversimplify this. If you're actually going from a 100 megabit connection to a gigabit connection, you need to validate to your customer that yes, it will provide better speed. 10 times more? Maybe not. Depends on the latency you have between each end. Then you do your calculation and you present it, and then you can validate it. As for the Nexus platform, there's a Nexus validation test. It's called NVT. For those that want to explore, it's on Cisco's website. Just check and for Nexus validation. Also under the build, we're at the deployment now. The deployment can be either a greenfield or a brownfield. If you're lucky enough to have a greenfield, well, good for you. Greenfield usually means we're building from scratch, or almost. A brownfield mean, well, probably it's a hardware refresh. Probably it's an addition to a current network. So, and this is more common. I mean, yes, you can get lucky, do a greenfield from time to time, but most of the time it's going to be a brownfield. So you're already working, I said Starbucks, but let's say now you're working at Costco and they're adding another branch. Well, add the branch is going to be a greenfield, if you like, but from the HQ adding a new branch, it's a brownfield. So new equipment is installed during the deployment phase. Descriptions, so everything you do needs to be described, needs to be logged. Implementation guidelines, at this point you should have implementation guidelines to follow. Estimated time, yes, because you will have to meet your windows, your maintenance windows. You need to estimate your time so that you can actually schedule a maintenance window. And one of the very important part here is the rollback steps in case of failure. This should be included in your implementation guidelines. It should be included in your estimated time, and it should also fit your maintenance window. Too often I see this. The maintenance window is 2 hours. It's the estimated time for the implementation itself. Well, if the implementation fell, now we're stretching the maintenance window. So we're outside of that time. So usually your rollback should fit within your maintenance window. So if it's a maintenance window of 3 hours and it's a 2 hours deployment time and a 1 hour rollback, well, the good news is if it works, it'll just give you more time to monitor and test. And more time is good. Migration, same thing, can be a greenfield or a brownfield, but those are for services or applications that are moved or deployed. So you're migrating application from data center A to data center B. That would be a migration. Services, you're migrating from a PAN firewall to an ASA firewall. That's a migration. Same thing. You'll need the descriptions, implementation guidelines, estimated time, rollback steps in case of failure, and the test. This is very, very, very important. Now we have the manage. So we went from the plan, the build, we're going under the manage umbrella, heading back to the plan again. So manage, we have 4 subtopics: product supports, solution supports, optimization, and operation management. So product supports, solution supports, I like to put those two together. It's your day-to-day operational health. So you're supporting the product. So a PSU, power supply unit failure, solution support. Well, the implementation of the MACsec didn't work that well with a certain hardware platform. Well, you might have to provide a solution. Monitor network components, like I said, PSU. And nowadays, I mean, you can pull a lot of information through SNMP. That's another thing we'll talk also under the CCDA. But there's so many things you can pull under SNMP that you can actually monitor the network components, identify the network faults. So you have this large SNMP collector, and you can probably yes, you can probably identify network faults. You can have traps and thresholds that will report. We're not necessarily talking about a port going down and up, but you could put threshold to detect flapping links, for example, or to detect traffic not exiting the right egress point of some part of your network. These can be identified as network faults. Considered the final phase of design. So with design, with deployed or migrate, or deployed and migrate, and at this point we are operational and we are monitoring the network. So this is why we called it, or we consider it the final phase of the design. The optimization. So let's recap a bit. You identified a customer goal, provide a solution, and you actually got the chance to deploy it. You got the chance to monitor it. Then you can easily see or prove that your actual design met the goal, barely met the goal, or did very good. I mean, good for you. I mean, that looks good on resume. But this is the part where we always go back to our baseline. So we identify and resolve the issues before they affect the network. So the speed of your network increased 5-fold. The backup is faster now, but for example, you have an ESXi host and the DRS was maybe a bit too aggressive, but now that your network is faster, you see mobilities of VMs too much. So they're moving just a wee bit too much. So now you need to resolve these issues. You may, at this point, also create or modify the network design. So your design is done, it's delivered. You might be called back or you might be on site to modify further the design, especially to improve the performance issues or resolve application issues. So, like I said, the DRS is too aggressive. It was an issue before because the network was slow enough that it would take some time for the application to actually migrate to another host. Now it's very fast, so you can almost see an application flapping. Well, that's something you would have to resolve. But also performance issues. Now you didn't have a point of contention at your aggregation because your access layer was only 100 megabit. Now it's 1 gigabit, and you did not foresee the overutilizations from some users. So yes, you might have to improve performance. You might have to identify the network flows and then flag those flows as less important on your network. So maybe you're going to be doing some QoS at this point. Requirement to modify the network might lead to life cycle beginning. So if at this point the requirements for your QoS, for example, is too high, you might have to actually go back to the plan and create a new solution. So your customer is very satisfied, everything is faster, but it created new point of contentions further in your network. Well, you might have to design new solutions. Operation management. So let's say you have a almost perfect design. Everything went smooth. You don't need to redesign part of your network, and you're not looking to go back yet to refresh or to scale your network. Well, you're at the operation management now. So you monitor the network general health. It's more of a general health. So you're not concentrating your monitoring on the new solution, but on the network itself. And now that you know that your implementation, either it's a migration or deployment went well, now you're going to be generating traps against a certain threshold. So you know the general health, you know how your network should behave. You can compare it to your baseline. So now it's time you set thresholds in a few places so that you can detect a fault. So that would be the fault detection. And the performance monitoring events to provide data for optimization. So at this point, you should be able to provide a new baseline. So this is going to be your baseline on forward now. So if at some point you saturate more links, well, you'll be able to compare.